And with that, we move on to our last but certainly not the least speaker. That would be Jukka Hirvasniemi from the Erasmus Medical Center. And that's part of our population imaging flagship node in the Netherlands. So please, Jukka, go ahead.
Thank you for the introduction, Asta. And I trust that you can see my screen and hear me well.
Yes, that's perfect. Thank you.
Okay, so thanks again, and thanks for letting me to present our challenge that we organized recently and the experiences on that. I will start shortly introducing a little bit background about osteoarthritis disease and also the imaging and the prediction that why we do it. So osteoarthritis it's the most common joint disease in the world, and it affects hundreds of millions of people around the world, and it causes a large economic burden to our society because it's so common. And the typical symptoms of osteoarthritis include pain, stiffness, and problems of moving the joint, and so it decreases really the quality of life of the patient. Osteoarthritis affects all tissues in a joint. There is no cure. The only treatment option at the moment is lifestyle changes, and at the end stage, you may need to replace the whole joint. And at the moment, we don't know exactly why some people get it and why some people doesn't get osteoarthritis. So that's also interesting research-wise, this disease. Osteoarthritis is typically diagnosed using plain radiographs, and plain radiographs are common, and the advantage of them is that they are cheap, quick, and widely available. But the downside is that they include ionizing radiation. There's a poor soft tissue contrast, and the images are summation of the 3D structure, so 2D images. Magnetic resonance imaging, on the other hand, is considered the most comprehensive imaging modality for knee osteoarthritis assessment. It provides a great soft tissue contrast. For example, the cartilage that is around the bones, which is interesting to the osteoarthritis, can be well seen. The images are 3D, and it doesn't use ionizing radiation. On the other hand, it's quite expensive. It takes a long time to scan, so the patient needs to be in the scanner a long time, and it's not that widely available for compared to the radiographs. So why we want to predict who will get the disease? So it's important to identify these subjects because we might be able to prevent or slow down the disease process if we find the patients in the early phase. Also, it would help patient selection in clinical trials to make better clinical trials and to try to find treatment for this disease. And it also increases our understanding of the disease. And from the previous studies, we know that imaging-based information is important for prediction. And as in many other fields, deep learning is nowadays increasingly used for the prediction. And in previous studies, for example, the radiographs have been used, and also MRI data has been analyzed and used as in a deep learning models to predict the disease. It should be noted that the data splitting and also the outcome variables, and also if the studies used external dataset to evaluate their model, how well it generalized to other dataset, it really varies, and it's not very common to use external dataset in the clinical studies. Dorian already a little bit touched on this topic, but in medical image analysis field, the methods are usually optimized for a specific imaging dataset, and it is unclear that how well the models perform on unseen datasets. And the challenges are great to compare the method because it uses the same test data and evaluation metrics. And the participants of the challenges do not usually have access to the ground truth of the challenges. And one common website for hosting the challenges is Grand Challenge website, which is actually part of this community, the challenge node. And there are at the moment over 300 challenges, past and current challenges listed in this website. Previous osteoarthritis-related challenges include segmentation challenges and interpretation of knee MRI challenges, but not prediction challenges yet. Therefore, we wanted to organize this knee osteoarthritis prediction challenge with the aim of using independent test set to objectively compare methods for prediction of incident symptomatic radiographic knee osteoarthritis within 78 months follow-up. So how we did the challenge, we gave for the participants knee X-ray images, two different kinds of structural MRI sequences, and also some background variables and risk factors for osteoarthritis. And all of these knees were, they did not have osteoarthritis at the baseline. And the task of the participant was to predict which of the knees will actually develop osteoarthritis within the follow-up. And the participant needed to submit us this kind of a file that for each knee in the test set contained the probability of that knee to develop osteoarthritis. We used data from a clinical trial that was done here in the Erasmus Medical Center, Rotterdam. And the participants were allowed to use any data to train their methods, but actually almost all of them used a dataset called Osteoarthritis Initiative, which is an open access dataset for osteoarthritis imaging and other analyses. So how we did it in detail? So we used the Grand Challenge website for the hosting the challenge. It was a vital part of this challenge, so we used it for registration. The participant needed to submit and sign a data use agreement before they could access to the website and also to the data, because this was a real patient data. Of course, it was anonymized, but still. We used this website to promote our challenge and also to give details of the challenge and data, and also links to the training dataset and also the test dataset, which was in XNAT, which I will in the next slide explain it, and also to the code repositories, because we made it available to how we compare the methods and also the metrics to compare the methods. And also the final predictions were submitted using the website. So the XNAT is an open source imaging platform, which is meant for managing, sharing, and analyzing medical image data. And the nice thing is that you can store images, but also the image-derived information such as segmentation and other kind of data in the XNAT. And we used the Euro-BioImaging Health AI XNAT for in our project. We created two different kind of projects in the XNAT. One was a kind of a project that contained only 30 knees for fine-tuning the models that the participant did, and this contained all the information, also the ground truth. And then there was the larger project with over 400 knees, and this was the actual test set in this challenge. And it went so that when we got all the documents signed from the participant, then we requested to create a user account to XNAT. And then we were able to share the large dataset securely for the patient, participants. We used a Nifty file format for the radiographs and MRI images because that allowed us to control what metadata or all the header information we share with the participant. And we also stored along the images the information about the manufacturer, scanner, acquisition settings, pixel and voxel size in the XNAT. And you can access the XNAT via a website, web browser, or for example, using Python. And we provided a simple script to download the images for the participants. We used around the rock to evaluate the models and also balance accuracy, because those are used in previous challenges and are relatively simple metrics. There were 7 teams that at the end participated this challenge. They came all over the world, and there were altogether 23 algorithms that we compared in this challenge. This is the full results ranked according to the around the rock curve, and you can see that actually the absolute values are not that different between the submissions, and also all of the models, all the algorithms. the teams perform better than the reference model without imaging data. And the final conclusion is also that the results are not that great, so there's still stuff to do to try to predict the osteoarthritis. This shows the results using balanced accuracy, and actually the ranking changes when we use these metrics. And I will explain a little bit, or this is not actually surprising because that's seen also in other challenges that the metrics you use, then you may get some different results. So the winner model in this challenge use X-rays and deep learning ResNet to extract information from the X-ray images and also clinical variables. And the second and third quest model used X-rays, MRI, and clinical variables, and they also extracted information using deep learning. It is interesting that the MRI-based model was not the best in this challenge. And as mentioned, the task was very challenging for the participant. It might be because there were imbalanced classes, so about 20% of the participants developed osteoarthritis during the follow-up. And we did not give any pre-computed features or segmentation for the participants, so quite some effort was needed from them to process the images. Also, there were differences in the training and test data. So the test data was collected in the Netherlands, whereas the training data, the osteoarthritis initiative dataset that I mentioned, is collected in the USA. Also, the imaging scanners and image acquisition settings were different, although the images look quite the same, so they resemble each other, but still they were different, which may affect the models. So as a conclusion, the prediction of knee osteoarthritis is a complex problem still, and maybe some other input modalities and data such as genetics should be investigated or quantitative MRI. And challenges are a nice way to identify and compare novel methods, but they require a lot of preparation. So you need to decide which task you want to predict, what data you use, what you can share, what outcome you use, what metrics, and etc. you need to decide. And also the XNAT and Grandson website were vital for the success of this challenge because there were participants from all over the world, and it allowed us to manage the data and share the data very well. With that, I would like to acknowledge Remo Nederland because they sponsored the prize for the winner of the challenge, also the challenge participant, and also the external and internal advisors of this challenge. Thank you.